Hi guys, so today we're going to be going over the polynomial function, so make sure that you have those notes out with you. Should look like this. So we're just going to review, talked about polynomials in Math 1, Math 2, and Math 3, but we're just going to kind of give an overview of what that is, reminders of how to use your calculator. So you can see this definition of a polynomial here. A couple things to note is that the x's are the bases. So something like 2 to the x power, where the x is an exponent, is not a polynomial. That's actually an exponential function. And also notice in standard form, our exponent should be decreasing by 1 every single time. So the largest exponent first, all the way down to your constant. So for shape and continuity, a polynomial is continuous everywhere. And it's going to be a smooth curve. So you've seen these before. And there's many different possible examples. They also, by definition, have a domain from negative infinity to positive infinity. Then for the degree, remember degree is the highest exponent. And that also, we're going to get to this more later, but that is equal to the total number of roots. Now remember, those roots could be real, they could be imaginary, but if it, for example, is degree 4, it's going to have 4 total roots. All right, so some quick examples here of degree. You should be familiar with this terminology, but this just goes 0 all the way down. Now you might be wondering where the 0 comes from. We can visualize this as 2 times x to the 0th power, and we know that anything to the 0th power is equal to 1. So that would just be 2. That would be called a constant, linear, quadratic, cubic, quartic, and quintic. So make sure you're familiar with that sort of vocabulary because we'll be using it a lot. Next, we're going to talk about end behavior. So end behavior, you did touch on this in Math 3, but we're going to use a little bit different notation. We're going to use what's called limit notation. We'll be talking about limits a lot at the end of the semester, but just make sure that you're using the correct notation here. So I always kind of think about 4 main parent functions or original functions: x squared, negative x squared, x to the third, and negative x to the third. Now x squared, we're talking about what's happening on the ends of the graph. So it's going up, up. Negative x squared is down, down. Negative x to the third is down, up. Or sorry, that's positive x to the third if I didn't say that. And then negative x to the third is up and then down. So to write this in limit notation, we write the word lim as x approaches negative infinity. That's what that arrow symbolizes. So that's talking about what's happening on the left side. So what's happening as x gets smaller and smaller and smaller? Well, it's going up, so that's going to be approaching positive infinity. We can say the same thing for the right side. The limit as x approaches positive infinity, as x gets bigger and bigger and bigger, it goes up towards positive infinity as well. So then for x cubed, it goes down and then up. So we're still going to always have 2 statements. As x approaches negative infinity is the left side. Now this time the left side goes down, so that's going to equal negative infinity. And then the right side, as x approaches positive infinity, that goes up, so that's still going to be a positive infinity. So go ahead and pause it for a second, and I want you to try the right 2 examples, and then I'll put them up on the screen. All right, so hopefully you had a chance to try that. This one is down, down, so they should both be approaching negative infinity. And the next one is up, down. So the left side goes up and the right side goes down. All right, so let's do a few examples without a graph. So when you don't have a graph, you're going to look at the first term. Down, notice that this one is negative and the power is even because it's to the 4th power. That's the degree. So negative even, although the graphs will look different, the end behavior will be the same. So this one will follow the same pattern as negative x squared, which was down, down. So the limit as x approaches negative infinity is going to equal negative infinity, and the limit as x approaches positive infinity is also going to be negative infinity. Again, the overall graph will look different, but the end behavior, what's happening, what direction they're going at the end, will be the same as the original functions we talked about. So then number 3, 6x squared is even and positive. So that one will go up, up. It will follow the same pattern as x squared. So limit as x approaches negative infinity is positive infinity, and the limit as x approaches positive infinity is also positive infinity. So go ahead and try numbers 2 through 8. All right, so next we're going to talk about turning points. Sure, still good there. All right, so next we're going to talk about turning points, which is when the graph switches direction. So to go from increasing to decreasing or decreasing to increasing. If the point is higher than any nearby point, it's called a relative maximum. So this point right here on that graph would be an example of a relative maximum. We say relative because I can see the graph goes up higher than that. So it's not the absolute maximum of the graph, but in relation to the points around it, it is a maximum. Same thing for this one down here. That's a relative minimum. Again, it's not the overall minimum of the graph, minimum, if I can spell, but it is lower than all the points around it. And maximum and minimum values are called extrema. So now we're going to do an example using the calculator. So I want you to get out your calculator and type this function into your calculator. Now I already have this one typed in. And you can see when you look at it right here, I can't really see the maximum, so we'll go up to that in a second. So it asks us to find both the maximum and the minimum relative. So I'm going to start with the minimum since I can see it there. You're going to go to second trace and then go down to the one that says minimum. We're going to ask for left bound and right bound. So left bound is somewhere to the left of that minimum. Right bound is somewhere to the right of that minimum. And then when it says guess, just hit enter again. Now this one is 0.6 repeating. I know what that is as an exact value. That's 2/3. So I'm going to write 2/3. And then always in this class for the rest of the year, unless I say otherwise, you're going to round to 3 decimal places. So that's negative 3.815. All right, and then relative maximum. So we're going to do the same thing. I do need to zoom out a little bit so I can see the picture. And I'm going to then change my window and just go up a little bit higher on my Y max, maybe to 100. Here we go. Now we have a better picture of what it looks like. So second calc, go down to maximum. And same thing, you want to go somewhere to the left, hit enter, somewhere to the right, hit enter. And then when it says guess, hit enter again. So this one's at negative 447. All right, so now what we're going to do is talk about the increasing and decreasing intervals. So I'm going to go ahead and just sketch a picture. This is at negative 447, and this one is at 2/3, negative 3.815. Now, whenever you're talking about increasing and decreasing intervals, we want to always use x values because it's talking about where the graph is increasing and decreasing. So I can see I'm going to color the 2 sections of my graph that are increasing. So that's from negative infinity to negative 4, again, using x values. And then also, remember, you join that with a u from 2/3 to infinity. So the decreasing interval is what's left over. There's no constant here. So that's going to be from negative 4 to 2/3. We are always going to use parentheses to represent increasing and decreasing intervals because technically at those points, it's neither increasing nor decreasing. So always parentheses meaning not included. All right, so we're going to do one example where you put this all together. All right, so go ahead and graph if you haven't already, x squared plus 2x minus 5 on the next page. All right. So x squared plus 2x minus 5. All right, so I can see it's a quadratic. It has one minimum, and the end behavior is going up, up. So I'm going to go ahead And first of all, to classify it, it is a quadratic. I know since it's a polynomial that the domain is going to be from negative infinity to positive infinity, and I can also see that in my graph. Now, in order to find the range, I'm going to need to find that minimum on my graph. So if we remember, second trace, go down to minimum, scroll somewhere to the left, hit enter, somewhere to the right, hit enter, and then when it says guess, hit enter again. Now, sometimes your calculator has a little bit of an error there with rounding. Notice this is negative 0.9 repeating. That's really just -1. Your calculator just had some issues there. So -1, -6 is the minimum. So I'm going to go ahead and graph that on here, and then I'm just going to sketch for now what the rest of it looks like. All right, so then the range, remember, is the y value. So we're going to go from the lowest y value to the highest possible y value. So it starts at -6. That is included because that's a part of my graph. And then it goes up to infinity. Remember, domain left to right, range bottom to top. For my relative minimum, it's going to be -1, -6. That's that point right there. There are no relative maximums. My increasing interval is going to be what I just highlighted in yellow. So it's going to start at -1. Again, we're using parentheses because that's not included in the increasing interval, and going to infinity. And then decreasing interval, I'm going to start at negative infinity and stop at -1. Again, -1 because that's your x value of your minimum. Lastly, end behavior. So this graph goes up, up. I can see it goes up on the left and up on the right. So to write this, the limit as x approaches negative infinity of f of x is going to equal positive infinity. That says the left side goes up. And then we always need two statements. So as x approaches positive infinity of f of x, that will also equal positive infinity. So up on the left and up on the right. So you'll have a chance to practice some of these where you kind of put it all together as well, but that kind of gives an overview of polynomials.